Hello everyone. So today I shall discuss about the Schrodinger equation, basically the derivation of Schrodinger equation. Just it's uh, for your knowledge, just to remember, it is not derivation. Okay, basically here uh, the intuition of Schrodinger lead to this equation. He didn't derive it in a proper way, but basically taking Einstein's equation equal to h cross omega, de Broglie wavelength, and some other thing. Just by intuition, he developed this equation. Okay, so this is not this type of equation, this type of derivation where uh, or you already see in thermodynamics or this kind of thing. So here, basically, this is one of the form of Schrodinger equation, and here H is Hamiltonian. Okay, the second form, it is basically for free particle. Okay, and here this H cross square is basically the Planck's constant, and it is Schrodinger time dependent one dimensional equation for free particle. Okay, and this is three dimensional equation for free particle. Now the thing is that what is the necessity of a Schrodinger equation? Basically, what Newton's equation does in classical mechanics, Schrodinger equation does so in wave mechanics, or you may say, you may write in quantum mechanics. So basically, to understand the world of subatomic particles or particle physics, you have to know this equation properly, and using this equation with some proper boundary conditions, you will get some astounding results to describe the subatomic world. So the first thing is, uh, what is the uh, basic thing of Schrodinger equation? So basically, this equation governs both the nature of a particle, the corpuscular nature and the wave nature. So first, there are some equations. There are some equations or some experiments Schrodinger's time that suggested that electron, basically one of the subatomic particle, has corpuscular nature. But in another hand, there are some experiments which also suggested that no, electron also have some wave nature. So we need, or the scientific community at that time are very hunger or eager to find out such equation that governs both these two nature of a particle. So using Newton's equation, it was difficult, or it is difficult uh, to 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 make it real, to understand the subatomic world. So we need some another equation basically. So to going before going the derivation of Schrodinger equation, you must know what is wave function. So student, you already know that wave function, just the y equal to a sine omega t minus kx. This is the equation of a wave. But here, what is wave function? The first, in a lucid way, I can say that psi is the solution of Schrodinger equation. So sir, what is this kind of? Because we are now deriving Schrodinger equation, and you are saying psi is solution to Schrodinger. Yes, uh, in very normal meaning, very basic meaning, psi is a solution to Schrodinger equation. Now the properties start. Basically, psi gives complete quantum mechanical description or behavior of a given particle. it cannot be measured directly by any physical experiment. Means you cannot get the value of this psi by any physical experiment. Whatever this property, but basically what happened, this psi just with the help of some suitable operation, mathematical operation, they gives basically the position, momentum, potential, and any maximum of the dynamical variables. Okay, so basically psi contains, inside this psi uh, there is all informations about the wave. Okay, and we can get it by applying some particular operations. The most important property of psi that it gives a measure the probability of finding a particle at a particular position at a particular time also. Okay, and size or you also complex quantity, because we took it as a complex. I shall discuss it later elaborately. Whereas the probability must be real and positive. So what does it mean? Basically, you see this side contains all the informations of the wave, okay, or the particle, the matter waves. So now probability means the probability of finding the particle in a particular region. Basically, we find it at like this psi star psi, where psi is the wave function and psi star is the complex conjugate of it. So the psi star is basically the probability to find a particle at a particular position and at a particular time also. Okay, so if this is elementary problem, this is like this, and you can get it this dB. Okay, right. Now the development of Schrodinger equation. So to develop Schrodinger equation, Schrodinger basically intuitively take these three equations, which are very familiar, which were also very familiar at that time. One is lambda is equal to h by p, the de Broglie wavelength. Okay, where h is basically Planck constant, h is Planck constant. Okay, and your p is momentum. Nice. The second one is Einstein's equation. E is equal to h cross omega. Basically, we know E is equal to h nu. Basically, we know E is equal to h nu. H nu. Okay. So you write it like this: 2 pi into 2 pi nu. So it will give h cross or h cut into omega. And the third one is, just to see if k is wave number. What is k? K is wave number. So this is equal to 2 pi by lambda. Okay. So now this p from here, this p is equal to h by lambda. Okay, so this will be basically this p equal to h by lambda. So you may write it like this: h by 2 pi into 2 pi by lambda. So basically it is h cross k. So here is another equation: p equal to h cross k. Okay. The fourth one is very basic equation in classical mechanics. E is equal to p square by twice m. Basically, Schrodinger took these four equations and he tried to develop an equation that may that may fulfill the purpose. So now what happened? Now you see, you have these four equations. just for summing up, I'm writing these four equations. Okay, so these four equations are basically I'm writing here. One is E is equal to H cross omega, lambda is equal to H by P, and your P is equal to H cross K. Here P is equal to H cross K, and your E is equal to P square by twice A. Now, as it is a wave function, so we may write it as psi xt, okay, equal to a sine omega t minus kx. We may write it as a cos omega t minus kx. We may write it as a exponential I kx minus omega t. We may write it as a exponential I omega t minus kx. All these are the wave functions, but basically to develop Schrodinger equation, you must take this one, because you know, as wave function has the properties of wave, so there is interference. But in case of quantum mechanics, this wave function will be of this nature, so that it can describe the development of wave packet. Okay, so consistent with this idea that this function is most appropriate. So this function is basically consistent with the idea of making wave packet. So I take this like this way, that psi is that your psi that your psi that your psi that your psi xt is equal to a exponential I kx minus omega t. Now there are two things. Okay, one is, as it is a two variable function, we perform partial derivative. Okay, so del psi del t is equal to a I omega with a negative sign, okay, and a exponential I kx minus omega t. So we get del psi del t is equal to minus I omega psi, okay, and there is h cross also. Okay, now I multiply it with I h cross. So I h cross del psi del t equal to minus I omega into I h cross psi equal to minus I square h cross omega psi equal to minus, because I square is minus 1 and this minus 1, so plus h cross omega psi equal to E psi. So we get energy basically takes this form, E equivalent to IH cross del del T. Okay, now the second thing, just you see what will happen, what is happening. Here also we take del psi del x. So this will gives aik exponential I kx minus omega t. So this del psi del x is basically I k into psi. A- Again I multiply both sides with IH cross. So we get this is I k psi into IH cross. And to understand what is happening, that I H cross del psi del k del psi del x, okay, is equal to minus, or is write like this, I square H cross k psi. This equal to basically minus p psi, because you know here p equal to H cross k. Okay, so I substitute this here and I get this. So now you also get that p, that this p is basically equivalent to minus I h cross del x. So you must remember that this p is momentum operator. It is also known as momentum operator, and it is known as energy operator, because when we operate this mathematical abstraction on psi, it it uh, it just squeeze out the value of energy of the wave function. Okay, so this is the energy operator, this is the momentum operator. Now we have very famous classical mechanical relation. Now we have very famous classical mechanical relation, which is E square, which is E square is equal to P square by twice M. E square, sorry, E equal to P square by twice M. Now I substitute it E. Okay, so I substitute this here. Okay, and I substitute this here. Okay, so what will I get? I H cross del t is equal to I minus IH cross del x, then whole square into 1 by twice m. So if I operate this thing with on psi, then what will happen? I h cross del psi del t is equal to minus I square. This again gives you 1. Okay, because minus I into minus I means plus I square. So this is minus 1 h cross square, and this 2m. So 2m, this is del 2 psi del x 2. Okay, now you just get this, that this IH cross del psi del t equal to minus h cross square by twice m del 2 psi del x2. This is one dimensional Schrodinger equation, time dependent Schrodinger equation for free particle. One dimensional time dependent Schrodinger equation for free particles. Okay, now the second thing,